Hello everyone, this video presents a simulation project for process modeling and simulation course at UAE University. The project we are working on is about an electric heating element that is immersed in a tank. A solvent at 15 Celsius with a heat capacity of 2.1 joule per gram Celsius is fed into the tank at a rate of 15 kg per hour. Heated solvent is discharged at the same flow rate. The tank is filled initially with 125 kg cold solvent at 10 Celsius. The rate of heating electric coil is 2000 watt. The first question is to write a differential equation for the energy balance, then to simplify the equations by inserting the suitable values, and finally is solving the differential equation using Simulink software. So, in order to solve part A in the question, first we use the total mass balance. Since the mass entering the system is equal to the mass leaving the system, that's why the accumulation term is equal to 0. Then we used the energy balance, where we wrote the energy balance equation. Then after doing some simplification, we end up with this differential equation. So in order to solve part B, we start by converting the unit of Cp from joule per gram Celsius to joule per kilogram Celsius, and we convert the unit of Qe from watt, which is joule per second, to joule per hour. Then just by substituting the values of the given information, we end up with this differential equation. That's why we need a Simulink in order to solve this differential equation. The reference for this project is the Book of Modeling and Simulation of Chemical Process Systems. We start by opening a blank module in Simulink and opening library to enter all the blocks we need. First, we go to the commonly used blocks and we select the integrator. And we put the initial condition of 10 Celsius and we change the name of the integrator to dt over dt. Then we go to the sink and we choose a scope block. Then we connect the scope to the integrator. Then we choose display and we connect the display to the integrator. After that, we go to the commonly used blocks and we select constant, which represent the initial temperature of the tank, which is equal to 15 Celsius. This constant will be subtracted from the obtained temperature. That's why we need a sum block. The value of the sum block will be multiplied by a constant that represents the mass flow rate divided by the mass. After that, another sum block will be added and it will be connected to the previous multiplier on one side, and on the other side it will be connected to a constant of dividing Qe by MCP. Which is equal to 27.429. And it will be connected to the integrator. Finally, we run the program, but before we run the program, we change the time to be 100 to show the value at steady state. That's why we put a large value for the time. So if we open the scope, we can see the value at steady state. And the final value will be displayed on the display block.